I'm Rossella De Gaetano. I'm one of the architects of the IBM Cloud Platform. By the way, I don't know if you're aware, but I'm working in the Rome lab and in Italy, and in Rome we have part of the Cloud Platform development. My goal in this talk is to walk through what we do in the IBM Cloud, which are the possibilities. I know I have something like 30 minutes, and it's going to take the time. My plan is to quickly remind which are the key features of cloud computing, and then I have an overview of the IBM Cloud itself. If we have time, I have a 5 minutes demo I really would like to show you. Otherwise, you will find me at the IBM booth on the other side. So, what's cloud computing? I'm taking the definition from the National Institute of Standards and Technology. And that's the only thing I'm going to read during this presentation. So, cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. Why I'm always start presentations with this thing? Because it sets the expectation, what I'm going to find into the cloud box. 5 essential characteristics. The first one is self-service on demand. What does it mean? I'm not going to write emails. I'm not going to do phone calls. I'm not going to go to a shop. I typically access an online catalog where I see what I need, I order it, and it gets provisioned, right? So what I'm going to expect also in the IBM Cloud, having a fancy catalog where I can order my services. Next thing, broad network access. One of the features of the cloud is that it exists. Nobody knows where, but it works, pretty much, right? So how do I access it? Through the network. Which device? With whatever device can be connected to a network. Can be an iPhone, can be a laptop, can be a mainframe, can be whatever you want. It needs to have a network interface. Other key characteristic. Resource pooling. So one of the typical things in cloud is that resources are grouped in pools. They are typically multi-tenant, shared through virtualization. Virtualization is not a must. One of the things I'm going to show you is that you can do bare metal in a cloud. Why not? Rapid elasticity. And that's one of the key things that people like the cloud most. You don't do any fixed investment up front. I need power, I will scale it up in the cloud. I need less power, I will shrink it. Typically, it's automatically ruled by policies. There will be auto-scaling services, for example, that you can attach to your application, or you can have your own manual policies. Depending on what you are doing, you can do vertical scalability or horizontal scalability. So what am I expecting in the cloud? At least an auto-scaling service, right? And the possibility to consume resources limitless. Actually, there is typically a limit that is your credit card. We need to remember it has to be paid. And we come to the last one, measured services. So whatever we do in the cloud, it has to be measured. I need to understand how many resources I'm consuming, how many APIs calls I'm doing, how much memory, how many cores, and so on. Why is that? Think about that. If I don't know the consumption of the resources, how am I going to scale? And then, if I'm the provider and I don't know the resources you are consuming, how am I going to bill you? One of the key characteristics in the cloud is that you really want to pay per use, right? That's one of the other fancy things. Next and last general slide. Cloud computing service models. 3 main ones. Actually, there will be 10,000 more according to your classification, but I think these are the most popular ones. Software as a service. And I will always start with that because that's the highest possible delegation that you can give. So I like something, I'm going to use it. It's typically an end-to-end application. Think about, for example, social, email, staff. It could be scheduling services. So it's something that works end-to-end. I don't know where it is provisioned, who's provisioning it. I'm just going to pay for that and use it, right? So I'm really just consuming something that somebody else built completely. There are situations, and that's the typical situation for software developers, in which I really want to invest in writing some of my own code on top of something. What could be the something? A database, for example, or an application server. Do I want to care about installing it, maintaining it, ensuring it's always up and running, it's scalable, it's clusterized, and all that nice thing, including security, compliance, patching, and all this stuff? If the answer is no, let's go with platform as a service. I press a button, somebody somewhere in the cloud is going to provision, for example, my nice database cluster. Which operating system it runs on? I don't care. It works. Fair enough. It exposes standard interface, typically REST interfaces. Nice, I can consume it, and that's it. Last but not least, infrastructure as a service. I really have to dig into the specifics of the operating system characteristics because of the nature of my application. I may want to run a DB, but I'm really meant to use the DB at its extreme capabilities. I'm not really happy with what the platform as a service catalog shows me, because I will have standard configuration. And I need that spatial tuning that can be done only if I install it by myself. Then that could be one of the options where you go with infrastructure as a service. What does it mean? It's a bare metal server. It can be a virtual machine. It can be a container. It can be an object storage. It can be a file storage. It can be a VLAN, whatever. If you need to get at that level of service, that's, as you can imagine, is the lowest possible delegation capability. I'm taking care pretty much of everything. The only thing the provider does for me is installing the operating system. Then pretty much I have to do everything by myself, right? But the cloud provider takes care of maintaining the hardware. That's still something. So, said that, why do we like getting things into the cloud? Because the business model is changing too much and too fast that pretty much we cannot afford the traditional development. I'm pretty much sure who of you does not have an iPhone or a smartphone? Everybody has one of that, right? A smartphone. What did happen when you get an app, a new app on your smartphone? You try it, you like it, you keep it, you don't like it, throw it away, get a competitor one. It's a quick choice. From the app provider point of view, you need to have a quick way to understand why the user is liking it, which user is liking it, which feature. If they are not liking it, why not? Go back to development, reiterate fast, and push it. So that's one of the reasons, I mean, cloud is cool. It allows you to do fast iteration with no really hardware investment, because the provider is taking care of all of that. Another scenario that is really interesting to me is that you can exploit quickly new technology. Think about that. I mean, the guy before was doing the example, 10 new JavaScript framework rose while we were doing the speech. Yeah. Can you imagine how many other programming languages are getting bored in the last week? I mean, this thing is rising exponentially, right? Can I always keep up with that speed? And imagine I want to consume a new middleware. There is a new DB, no relational DB. I mean, there is a lot of them popping up every day. And if I want to try it in a traditional environment, I need to pick up the hardware, pick up the right operating system, learn how to install it, learn how to configure it, start playing with that. Typically, I waste days or even weeks in that. In the cloud, the service may already be there. I click a button, the service is up and running in minutes. Play with that, I like it, I keep using it. Maybe I develop my application in the cloud. Maybe I take it in production in the cloud itself, or I don't like it, I use the cloud only for my sandboxes for playing, take all what I learned, put it back on-prem, right? That's another key scenario. Move fast, there is no time. So let's jump into the IBM cloud. It's a cloud, needs to be accessible through the network. That's how you get into that. First thing you want to do is signing in into the cloud. Interesting enough, the only thing you need for the initial registration is your email address. No credit card, surprise. So what's going to happen? You register for the first time, you get access, of course, capped with a quota, to the services that have a light plan. So you are limited on the resource consumption, but it's free. It's completely free. What does it mean? With the resources you are given, you can play with the technologies, get familiar, do small prototypes. You like it, add your credit card, and keep playing seriously. You don't like it, do something else. We hope you like it. So that's one of the key things. Then, I promise you there is a service catalog. What's inside the catalog? Something like 170 services. The number is increasing pretty much every day. Can you find into that? Actually, let me see if I can show it live. There it is. Two main sections, infrastructure and platform. Into the infrastructure as a service section, what are you going to find? Things like bare metal server, because you may be really in the need to get a bare metal server for your specific application stuff where you need special tuning. Virtual servers. The interesting thing with virtual server, you can get IBM virtual servers. You can get VMware virtual server, like you're tired to maintain your virtual server stuff, VMware stuff. You can onboard your template there and run them there, or use our own templates. What else you find in infrastructure? Whatever is in the storage family, block storage, file storage, object storage, networking. There will be things like, of course, silly things like creating a VLAN. There will be things like creating a firewall, things like getting an hardware-based firewall or a dedicated firewall. And of course, security stuff, DNS, CDN, and all these fancy things. And definitely container. What you will find in containers? There is a talk of my colleague later on this afternoon. You will have Kubernetes containers. Cool thing there, if you use our image registry, every time you instantiate a container, automatically we do the security checks for you at instantiation time and during the life cycle. So if, for whatever reason, a vulnerability is discovered, you get notified. Platform. Here, actually, it's in the platform section, but you will find things that are also kind of software as a service. Like, if you think about everything in the family of DevOps services, code repositories, Jenkins servers, translation system for your language files in your application, monitoring and logging, things like auto-scaling. What else you will find there? Application services and APIs. In the APIs, there is actually, we're using the real catalog so I can show you. There is this API Connect. That's pretty interesting. The guy here that was talking about mainframe. Mainframe are still used. They're not going to disappear, even though, I mean, a lot of people are moving to the cloud. So I have my interesting old-fashioned COBOL-based mainframe application, and I would like to give it a new fancy web interface on the cloud. This service is going to help you building a REST API layer on top of that. So that's why I'm mentioning it. Joining, I would say, the old traditional world with the newest technologies. What else you can find here? Blockchain. Blockchain is the thing that is promised to revolution the world of transactions, especially in banking. Other interesting things, data and analytics. In this section, you will find dozens, really dozens of services related to database management system, relational like DB2 data warehouses, and non-relational. There could be MongoDB, there could be Elasticsearch, Redis, Cassandra, Spark for analytics, HDFS. I mean, it's a lot of them. Weather management things, you will find them here because it's in the family of big data. Interesting enough, you will see in the catalog there are not only IBM services, there are also third-party services. There are community services. You can build your own service and ask us to host it into the cloud. And of course, you know, end user will be consuming your services hosted on the IBM cloud. Other interesting things here. I'm not going to walk through all the 170 services, just be relaxed. Internet of Things. Everything you need to help you building your Internet of Things application, monitoring and testing it, you will find it into this thing. You will also see something that are pretty interesting, like tailored solution for Internet of Things, like, for example, tailored for insurance, tailored for driving scenario, tailored for geospatial analytics. They will be into this family. One of my favorite, cognitive stuff. Yes, you can see from my t-shirt. Here you will find all the cognitive services. What can you do there? Starting from silly things like language translation. There will be things like text to speech, speech to text, so converting vocal to text and vice versa. There will be interesting things like conversation that will allow you to build a chatbot really in minutes. Something more sophisticated like tone analyzer and personality insight. Imagine that in customer support scenario or in marketing campaign where you can understand the personality or the mood of a user. Jump into visual recognition stuff to understand what's inside pictures and movies, and discovery to do complex cognitive analysis on unstructured data, plus even more complex things like natural language classifier and natural language understanding that are the key blocks to build cognitive application. Let me go back to the presentation because just I want to highlight this thing, boilerplates. I purposely didn't talk about that. What is a boilerplate? Boilerplates, it's a simple application that is used one of the common programming languages like JavaScript or Java or Go or Ruby or PHP, plus one or two services or even more than that. And it's an end-to-end application that you can deploy, play with that, download the code, modify the code, push it back to the cloud. The interesting thing is that pretty much all these guys here are using light plans, so they are for free. You are not consuming money. Why we offer them? Because imagine you are not familiar with Cloudant and you want to start using Cloudant in your application. You don't know how to use it. There is a boilerplate for that. You click it, instantiate it, start seeing how it works, start looking at the code, and quickly get familiar. Because if you remember the beginning of my presentation, speed is key. The market is moving fast, business models are coming new, and you don't have time to study everything. I also don't have time to study everything. So let's leverage something that somebody else built. And if you're already familiar with the technology, instead of starting from a boilerplate, what you can do, you start directly from a runtime. What is a runtime? It's actually the middleware that allows you to build the application. What can you find there? Liberty for Java, Node.js, PHP, ASP, Ruby on Rails, Go, Python, Tomcat. As you can see, there is no assembler because we have to be platform independent, of course. You don't know where the cloud is running. I even didn't tell you which is the operating system. But I will tell you one thing. A lot of the stuff I've shown you, including the platform itself, it's based on open standards. The IBM Cloud is currently, as far as I know, the biggest Cloud Foundry installation on planet Earth. Some of the services are using OpenStack services. Some of them are also exposed in the catalog. We have things like serverless services based on OpenWhisk. So no more vendor lock-in. Kubernetes. We try to be as standard as possible because you need to protect your return on investment. As I told you also, the platform itself, it's built on open standard because ourselves, we have to protect our investments. Last but not least, if you are interested, there is an IBM community, cloud community on Facebook. You can get registered. It's for free. You get notification of what's happening. You can ask questions. I'm part of the community. A lot of other guys interested in Bluemix, not only IBMers, are part of the community. And since we may still have time, I really would like to show you a demo, and then we open up for questions. And I know I speak fast, but if you have question I won't be able to answer during this talk, come to the IBM desk. And let's have a look at the movie. What is in the movie? Besides my picture, before we started, the original movie was 9 minutes. I cut it to 5, just to give you an idea. What the movie is going to do? log in into the IBM cloud. I'm already logged in. Create an application from a boilerplate, attach DevOps services, modify it, push it back to the cloud. So I go to the catalog, select one of my boilerplates. This is a CloudMDB web started based on Node.js. I give it a name. Automatically, you get a domain and host name. You have to choose the region where you want to provision that thing. Here you can see which are the involved pieces in the cloud. Pricing plans. And as you can see, it's free, pretty much. Gets created. As you can see, it's starting. Here you will see all the instruction if you want to download the code, if you want to use the IBM Cloud command line, and whatever is needed to make you start. If you get bored of using the command line or it's the first time and you don't want to do that, you don't need to do that. Let's just give it a few more seconds, and actually you can start seeing the details of the application, and the application is started. As soon as it starts, you can see the key information here, including the billing, how much you're going to pay for that. And the application, it's a real application. It's already accessible through the internet. It's a silly application where you can store whatever you want. In a CloudMDB, I'm uploading my picture just to show it's working. And because I'm a little bit egocentric, so I had my picture. And just remember the title. That's the thing we are going to change. So we have an application running. What do we do here? If we scroll down, we have a nice continuous delivery. If I enable that thing, I'm going to instantiate a set of DevOps services. The majority of the DevOps services, I don't remember if them all, they are for free. Why is that? Because if you don't do continuous delivery, there is no way you're going to be successful in the cloud. So we would like to give you all the tools to empower you to be successful. Where is it going to store the code? On GitHub? Yeah, another standard. And here are the things that are going to be generated. A place where to store your issues, so the life cycle of your code, and which are the requirements, the issues, the bug, and whatever you have. Here it is. Next one I'm going to show you is the code repository. So automatically the code has been loaded as a GitHub repo. And of course you can download it and play with that. A delivery pipeline has been built automatically. And here you may recognize Jenkins under the cover. Another, I would say, de facto standard for continuous delivery pipeline. You can add as many jobs as you wish. Of course, in this case, it's silly because it's JavaScript code. The compilation step is nothing than cloning the repo, sorry. And the deploy is actually pushing it in the cloud. You also get an embedded code editor that is Orion. So what we are going to do now with this editor is simply do a silly modification to the code. I will change the title. There it is. That was the old name. I'm going to give it a new name, my demo. And Orion is integrated with Git. You will see the icon at the top left corner. And so immediately you will see the change I've done into the incoming changes. I can do a commit and then a push. Nothing special, it's just Git, the way Git works. Why I'm showing you this? Just to show you that in a few minutes, you can have a fully integrated continuous delivery pipeline. Of course, as much as your application gets complex, this thing gets more complicated. But the idea is that if you want to do the whole development end-to-end in the IBM cloud, all the pieces are there. So I did my commit. I'm pushing the change into the code. What's going to happen? My delivery pipeline that is under the cover Jenkins server, it's configured by default to on push redeploy the code, rebuild and redeploy. So build is done, it's JavaScript, there is nothing to compile really. And now it's deploying the changes into the cloud. So let's give it a minute. It passed. That is my application. And if everything went well, there is a new title. The stuff that I stored into the DB stays into the DB since we didn't change anything, right? And that's pretty much it. Questions? No questions, everybody's scared.
Thank you. Yeah, question time.
Saying that I'm waiting with you for the taxi, and I'm a big manager in a large company that is not using cloud technology. Instead of talking about Weaver, how can you convince me to adopt this technology in, say, 20 seconds, a few sentences?
By the way, I can show you this on a mobile.
No, 5 minutes, too long.
Well, the quickest thing I'm going to ask you is that, I mean, I would say I will be using, the traditional things related to cloud computing. So how much money are you spending or blocking into hardware investment? How much money are you spending in buying software licenses that they're not staying on the shelf because you don't use that? How much spare hardware you need to have to manage your peaks? And by the way, there are things here. We didn't spend time in dealing into some of the services, but there are some of the services like the cognitive ones that, I mean, pretty much nobody really wants to store at home. You like the functionality, but they are really power consuming, hardware consuming, resource consuming. So you really want to connect to that thing for a few minutes and play with that and use it. And then if you don't use it, forget about the hardware maintenance, power supply, and all that other things.
Thank you.
You're welcome.
Which is the main advantage compared to Amazon AWS, for example?
Okay. First thing, I'm not going to do any competitive analysis. The other thing is that if you want and if you have time, I'm going to take you through the all 170 services and you will get an idea. Another thing I'm going to add, and actually we didn't talk about that. I mean, this thing, I showed you the public version. Exactly the same thing with the same set of tools can be done in a dedicated fashion, means hosted by us somewhere on the internet for a single customer, completely isolated from hardware point of view to other customer with a dedicated catalog. And the same nice box customized for you can be done on-prem. But if you need to have more details, we don't talk it right now about that. But we can walk through all the 170 services if you're interested. Sorry.
One question. Suppose that I want to use your platform, that at some point I'm going to buy something. And one day I realize that I want to host these things on my own premises. Can you show me how to export the data, how to export the infrastructure so that I can clone it on my system?
Okay, there is a few different set of options. If you're using virtual machines, for example, in some cases, like the simplest case, VMware, you hosted it on the cloud, you are tired, pack it, you have your image, move it on-prem. All the other things that I showed you, like even the platform as a service ones, the application that I've shown, it's Node.js. So you take Node.js, install it on whatever system you have at home. The code is downloadable from here. You push it into your application. Databases, I mean, there is no special feature. Databases will have their backup and restore procedure. You can export data.
Wait on.
You can download.
I mean, can I do some export somewhere? I can download it and put it on
I didn't log in
box?
here, but if you get into here, for example, in the container registry, same story for virtual machines, same story for bare metal server. You have the list of images you can download, and there will be the template, as well as you can save your own image and download it. as you would do with whatever other provider. There is no magic there.
Are there any other questions?
The other thing, actually, let me add one more thing. One of the scenario is becoming hybrid. Like I would like to have a piece of my application running on-prem, something else in the cloud. Nothing easier because everything gets exposed to REST API. So as far as you have network connectivity, you can do that. Also, another thing you can do is mixing and matching clouds. Like I'm using service A from this cloud, I'm using service B to from the other cloud. My main app is running on-prem. There is nothing bad with that. You pay as you go. All of us will expose standard interfaces. You're done.
A question about configuration. Let's assume my application has access control or similar, and I want to store my private key in a way that the configuration is secure. I do it from the interface. I have an API to provide the configurations.
We are talking about the security of accessing your application.
Yes, like a certificate or some passwords.
You can do things. I mean, there will be services that will allow you to store secrets.
Great. Thank you.
I think it's a standard policy in the cloud world. Like, you don't want to store things hard-coded anywhere.
Sorry. Yeah, it depends on where do you have to use the services from a specific web interface, or if I have to...
Everything from here.
Okay,
so there will be things like key protect. It's a secret storage, right?
Great.
Okay, we have time for more questions if you have. Okay, no question. Thank you, Rossella.